Hello, we're going to go over some derivatives of inverse trig functions. Here we're doing the derivative of an arctangent. So let's look at the formula for the derivative of an arctangent. So this says that the derivative with respect to x of arctangent of some function of x is 1 over 1 plus that function squared times the derivative of that function with respect to x. Now this part right here is just the chain rule. It's saying, so the arctangent, the derivative of arctangent is 1 over 1 plus u squared. But since u is a function of x, the chain rule says we then have to take the derivative of u with respect to x. So let's see what that means over here. So the derivative of arctangent, and now this is going to be our u, right? So the derivative of this arctangent is going to be 1 over 1 plus, and then this whole part squared. So x squared plus 3x squared times du dx, so the derivative of the inside. The derivative of x squared plus 3x is 2x plus 3. So that's 2x plus 3 over 1 plus x squared plus 3x quantity squared. Now, sometimes they'll have you go ahead and multiply out. If it's a multiple choice test, they might leave it like this, or they might want you to multiply out the x squared plus 3x squared. And if you want to do that, I'm going to do that over here in blue. X squared plus 3x times x squared plus 3x. X squared times x squared is x to the fourth, plus x squared times 3x is 3x to the third. Then here we're going to x squared times 3x is another 3x to the third. And then 3x plus 3x is 9x squared. So we get some like terms right here. So this is 2x plus 3 over x to the fourth plus 3x to the third plus 3x to the third is 6x to the third plus 9x squared plus 1. Ding! So next we're going to do the derivative of arcsine of 1 over x squared. So here we got arcsine of a function of x. So that's going to be like this, where we're doing the derivative of arcsine of a function of x. And the formula for that is going to be 1 over square root of 1 minus the function squared. Oops, I wrote mu. It's just supposed to be u times the derivative of the inside function. So times du dx. But in this case, we're not just doing the derivative of arcsine of a function, but we're also applying a function to the inverse trig function. So we start kind of from the outside. So the derivative here is, first we're thinking of the power rule. We're going to bring down the 2, and then multiply in the front. Arcsine of 1 over x, and then the power reduces by 1, so that just stays. Now we're going to do times the derivative of the inside here. So now we need to do the derivative of arcsine of 1 over x. So and that's when we're using this. So times 1 over the square root of 1 minus. Now the function we're doing is 1 over x. So 1 over x squared, that's this part, times the derivative of the inside of the arcsine function. The derivative of 1 over x is negative 1 over x squared. So now we just need to do some simplifying. We'll have a negative, and then a big old fraction bar. And then on the top, we're going to have 2 times arc sine of 1 over x. And on the bottom, x squared times the square root of 1 minus 1 over x squared. This is a 2 and not a z. 2. Ding! Next we're going to do the derivative of arc cosine of 4x. Now the derivative of arc cosine, derivative with respect to x of arc cosine of some function of x, did it again. That'll happen when you teach stats and calculus at the same time. U, not mu. So the arc cosine of u, which is some function of x, it's close to arc sine. It's just negative. 1 over the square root of 1 minus u squared times the derivative of the function inside. So times du dx. Okay, so arc cosine of 4x. The derivative of arc cosine is negative 1 over the square root of 1 minus u squared. Well, u is our 4x, so that's going to be 4x squared times the derivative of 4x. The derivative of 4x is just 4. So if we simplify a little bit, we will get 4 over the square root of 1 minus 16x squared. Ding! So hopefully those examples show you how you use the chain rule along with the formulas for the derivatives of inverse trig functions. Bye-bye.